This meeting is being recorded, and the recorded version will be uploaded to the website within a week's time. We will also upload the slideshow from this presentation. Oh, Eric, I'm just going to mute during this because there's some background noise. Okay, there we go. There's a chat box on the right-hand side of your screen. If you have any questions or are looking for clarification, go ahead and put that into the chat box, and I'll be monitoring that throughout the presentation so that I can respond to those. And I think that's about it. So without further ado, I'm going to hand off the presentation to my colleague, Erica Carlson, who is going to tell us more about the Douglas Community Center Stormwater Retrofit Project. Erica, take it away.
Thanks, Cecilia. Good evening, everybody. I hope you're doing well on this cold night. I'm really happy to be here tonight to talk to you about the Stormwater Retrofit Project that we're doing, the Department of Energy and Environment with the Department of Parks and Recreation and Natural Resource Design. So like Cecilia said, my name is Erica Carlson. I'm an Environmental Protection Specialist in the Watershed Protection Division at DOEE, the Department of Energy and Environment. And I am just really, really happy to be here with you all so that I can tell you about this project at Douglas. And I'm going to be doing a bunch of different projects on DPR properties in the next few years. What I'd like to hear now is from Cecilia, Peter, and Lauren from Natural Resource Design, if they can just give a brief introduction of who they are and how they're going to be involved in this project. Let's go ahead and start with... Oh, sorry.
No, that's all right. I was assuming that order. Thanks, Erica. My name is Cecilia Lane. I'm also an environmental protection specialist in the Watershed Protection Division of the Department of Energy and Environment. I work on large-scale environmental retrofits around the district, and I'm also excited to be here.
Hello, everybody. My name is Peter Norden, and thank you for joining us tonight. I'm with DC Parks and Recreation on their capital planning and projects and design team. So we're working closely with DOEE, and we really appreciate this opportunity to do some major renovations to the park and help with some of the stormwater runoff and making sure that we have better and cleaner water in your community.
And my name is Lauren Wheeler. I'm the owner and principal of Natural Resources Design. We are the design build firm that has designed this project and will be overseeing the installation of this project.
All right, thank you all so much. Go ahead and move on to the next slide. Our agenda for this evening. First, we're going to focus on the project area and background. So what part of Douglas are we working on, and the background as to why this is important. We'll go over the existing conditions, what's currently there at the site. We'll go through the project objectives of DOEE's work, what our restoration approach is to get this land back to an environmentally sustainable level, the construction details, which I'm sure you're interested in as a community member, the timeline of the work, some facts, and then we'll have a short Q&A session at the end. And just a reminder, if you have any questions, if you want to go ahead and add them into the chat box, we'll be sure to answer those questions at the end in the Q&A session. All right, so the project location, Frederick Douglass Community Center is at 1922 Frederick Douglass Court, Southeast. And if you take a look, it's a pretty large site. There were some plans to do some work to capture stormwater runoff in several different parts of the community center. However, DPR is going to be doing some work there in the coming year or years. Peter can fill you in on that later. On the other side, which is where you see the building and the pool, where we're going to work is going to be over by the court here, the basketball court. And so that will be our project location for this project. But before we get into the details of the project, let's talk a little bit about the background of the work that we're doing. So this image here is showing you water balance at a developed and underdeveloped site. So what we're talking about here is pre-development and post-development. So just to give you an idea of what we're talking about, before humans came and built their buildings and their homes and everything, the Earth's surface had tons of vegetation. I mean, you could just think about what it was like in historic times. And so there was tons of vegetation all around, but there were also good soils underneath that vegetation. Those soils act like sponges and they absorb water. So when there's a rain event, instead of it running off, it's going to absorb into the earth. And at that time, there were very few, if any, hard surfaces to create stormwater runoff. In those times when rain fell to the earth, most of it was used by that existing vegetation. And if you're trying to think of what present day might look in this area in DC, maybe you think of like Rock Creek Park today, a few other parks where it's just extremely vegetated. Anything that was not used and infiltrated through soils would be returned to our rivers and streams. That's the most important part of this, is our rivers and streams. As you may or may not know, in DC, all the water runs into the Potomac River, which ends up going to the Chesapeake Bay and then out to the Atlantic Ocean. And so anything that we do here in DC impacts the larger fisheries of the Atlantic and further into the rest of the world. So in this image, you see arrows, and they represent the amount of water that's moving. And so large arrows represent more water and smaller arrows represent less water. Pardon me. In pre-development, there was a balance of these flows. If you take a look on the left, you can see evapotranspiration, canopy, interception, surface runoff, interflow, and base flow all are about the same level. In pre-development, there was a balance, as you can see. Now, if you move over to post-development, you can see that the majority of vegetation in populated areas was removed. So just think about when we started to come into areas and tear down trees and build our buildings. You know, a lot of things happened to the environment. So we had vegetation that was removed, land was compacted for buildings and recreational amenities, and the building of hard structure and impervious surfaces. Impervious means that water can't filter through it. And examples of that are going to be your roadways, your rooftops, your sidewalks. In this post-developed world, we have a reduction of rainfall returning to the atmosphere with evapotranspiration and the amount of water going into our soils and back into our streams and rivers. And there's an increase, as you can see that really, really large arrow on the right side, there's an increase of rainfall in the form of surface runoff. And that is stormwater runoff, which ends up in our rivers. So here's the big question. Why do we care? Well, this is really important. Like I said before, how does it all connect to what you do, what we do? You know, this is going to impact your drinking water. It's going to impact if you go down to Florida to have a vacation, you know, what happens upstream impacts what happens downstream. And the problem with stormwater and why that impacts that downstream is that it's hot, it's fast, and it's dirty. So just to remind you, stormwater is that water that's going to run off of surfaces that can't absorb it or infiltrate it. So let's talk about those three things: hot, fast, and dirty. Hot. For example, if you think about the summer and you're walking around on pavement or you're playing with your kids in the playground, the pavement's pretty hot. You know it's hot. So that's an example of what we can think about. Hotter than in pre-development times, this created what we call thermal pollution, which negatively impacts the local aquatic system. Just think about what happens if you stick a goldfish in a fish tank without letting it get acclimatized to the new temperature of that fish tank. Not so good for the fish. The other thing we want to focus on is fast. Remember, we said hot, fast, and dirty. Fast, with no vegetation to soak up the water into its roots. This water is going to move really, really quickly down this impervious soil, impervious surface. There's no soils to infiltrate the water. And so it's all going to come quickly downstream along the pavement with huge forces. This is like a pressure washer or a fire hose. It can erode the stream, like in the upper right picture. As you can see, this water that is coming out into the stream, it's just eroded the bank from like 10 to 20 feet, and it's much lower than the stream bed should be. So that's what we're talking about when we talk about fast. The third one is dirty. This is one we're probably a lot more familiar with because we see it. We see it all around our neighborhoods. We see it in our rec centers. You know, there's pollutants that water picks up along the way. If there's a really big storm and you start to see this water flowing down the street, what do you see that comes with it? You see trash. Look at the right bottom corner. Where does that all end up? In our streams, in our rivers. But there's some things we can't see. For example, that nutrients like nitrogen that are in fertilizer, dog waste, heavy metals, oils, grease, we can see some of those. But anything that would be in your parking lot or on your sidewalks that's impervious surface is going to go down into those streams and rivers. So really what we're focusing on here is imperviousness. That's the real problem. If you have this surface, right, like we have today all over the city that is impervious, water can't go through it, it's going to be fast, it's going to be dirty, and it's going to be hot. Our goal in the district is to slow it down, cool it off, and clean it up through our projects. So here's an image of the total area of DC. So the total area of the district is 68.3 square miles. Of that, there's 61.3, which is land. The rest are our rivers and streams. Of that, the impervious area is about 43% of that land area. Now, we're really lucky in DC compared to some other cities because we have some pretty large parks, but that doesn't mean that we are scot-free. We still have a very large amount of impervious area. And in order to get our waterways clean, we need to really work on fixing some of that.
Erica, may I jump in for a moment?
Sure.
If I'm understanding what you said correctly, that stormwater is really an issue of impervious cover. And this map demonstrates how much impervious cover is in the district. And so we're trying to mitigate the impacts of that impervious cover through these projects. Is that?
Yep. Mm-hmm. That's correct.
Great.
Is there anything else?
No, just going off of your slide here, that when we have our most common storm event each year, which is up to 1.2 inches or less, that can any single one of those storm events can generate about 25 million gallons of stormwater runoff by landing on the impervious cover within the district. So that's what we're really working to capture and address.
Yeah, thank you so much. A 1.2 inch storm event represents 90% of the storms that we get in DC each year. So like Cecilia said, that's what we're focusing on in these practices is our 1.2 inches or less. So that means that of all the storms that we have in the year, 90% of them are going to be 1.2 inches. What we don't capture are things like massive hurricanes, floods, like a 3-inch storm. But our goal is to capture the majority of the storms. Something else to think about is this concept of the first flush. So why do we focus on those 1.2 inches? 1.2 inches is the amount of water in which you're going to have the majority of the pollutants flushed out and make their way into the stream. So we want to treat that rainfall event. All right, so you may be familiar on the map of DC, the difference between the combined sewer system and the municipal separate storm sewer system. We have two different sewer sheds. The combined sewer system is the area where you have stormwater runoff from roadways mixing with wastewater. That's the area where DC Water is focusing efforts in building large underground tunnels. The other area is the area that we're focusing on because it is untreated water. It goes from the drain to the pipe to the stream. And so without the practices that we're using, there will be no infiltration or management in between. All right. So now that we have the background, let's talk about the existing conditions of Douglas. Like I said before, DPR has plans to renovate the recreation center, so we're focused on capturing stormwater from the basketball courts. That will remain. The water flows from the right top corner of these basketball courts and makes its way into the very bottom left corner. So as you can see here, here's the basketball courts, and all the way to the left is where the majority of the water is going to drain. Now, there was a previous bioretention there and a concrete swale. As you can see on your left, this is a bioretention. It had been filled with a lot of invasive species. And as you can see, it's just not very deep, and so it's not really treating the stormwater. So we're going to be focusing on these two sites as a part of our project.
Hey, Erica, this is Cecilia. What is a bioretention?
Yeah, I'll go through that in just a minute. So going back, this area here, if you take a look on this concrete swale, it ends up going here into this inlet. And so this is our existing area. And this is probably the most important issue that we've seen at this site. We've seen this water, see if you can see here, it's actually pouring over into the street, and it's coming from this area right here because the bioretention area isn't capturing it. So our project objectives are to treat the maximum amount of stormwater from the site in the most cost-effective way. We work only on district land, and that's because of our funder. And we want to have minimal impacts to the community so that you all can still enjoy and use those recreational amenities. And develop a community amenity there with the beautiful plants and the installation, and provide educational opportunities. All right, so Cecilia, now we're going to talk about all those things I just mentioned, the bioretention and the bioswale, and our restoration approaches. All right, so when we talk about these best management practices, our low impact development, there are a suite of these stormwater practices to choose from, and they all work similarly. They collect water and use techniques to mimic the natural environment to create a balance in those areas. So there's less runoff and more evapotranspiration and infiltration. There's more vegetation to capture water and to use. And so you're slowing down the water, you're spreading it out, and you're soaking it in. All right, bioretention. So a bioretention area is going to capture the water from the stormwater runoff and to filter it in. An example on the left is in a suburban environment. And you can see that that area, which is sunken into the ground, is different from the surrounding turf, but it takes stormwater from the parking lot just the same. On the right, this is an image of a bioretention outside of DOE's office in Noma. It takes stormwater runoff from the adjacent roadway, slowing it down, filtering it, cleaning it, and then returning it to the stormwater sewer system. And it'll be cleaner than it was before. So how does bioretention work? So stormwater will flow into the practice and it will temporarily pond. I'm just going to go back real quick. As you can see, the water flows in to the practice, it temporarily ponds, and then it will filter through what we call an engineered filter media. As you can see, it's filtering down. This consists of an intentional soil mixture. Then some of the vegetation will utilize that water and return some of it to the atmosphere, thereby reducing the amount of water that we are dealing with overall. Water will slowly filter through that filter media and then ultimately drain through what we call an underdrain. That's this part here, which you can see that moves to the right. It looks like a drain. Through what we call an underdrain, or it will infiltrate into surrounding soils depending on the design chosen. So even though the ponding is temporary, these systems are designed to drain within 72 hours Oftentimes we find that they drain as quickly as 4 hours. There may be water filtering through the lower portions over time, but the upper portion drains first. We're also going to be using a bioswale. Just wanted to let you see a few images of a bioswale. They're linear vegetated ditches, which allow for the collection, conveyance, or movement of water, filtration, and infiltration of stormwater. They can also be referred to as grass swales, vegetated swales, or filter strips. Great. Now, before I move on to our final designs, I just want to check in with you, Cecilia, and see if you wanted to add anything on these restoration practices.
Thanks, Erica. I think you did a really good job discussing how we use low impact development to bring us back to those pre-development conditions. Basically just follow what Mother Nature was doing all along. I guess I would like to mention that this particular site where we're working already had a stormwater management practice on it. However, it was designed under older regulations, and so it wasn't working as hard or doing as much as it could be doing. So what we're doing through this project is taking that older stormwater practice that was designed under earlier regulations and is not quite as good for water quality and bringing it up to today's standards. Also, Erica showed that picture. It really hadn't been maintained very well, so it wasn't having the same impact for our waterways. So that's the big thing, is that this isn't a new practice necessarily, but a rehabilitation of an older practice.
Thank you so much for bringing that up. And that's a great segue to our design portion. I'll be tagging people in to ask them to contribute to this portion of it. If you can see, those arrows here in this final design on the basketball court are showing you which direction the water is flowing. And as you can see, that little area that's darker blue and green, that's our BMP, that's our bioretention basin. That is what's going to filter in the water to capture it. And to the right of that is going to be a grass swale. Currently, there's a concrete swale. So our final design is just to change this bioretention so it's capturing the water and it's managing that 1.2 inch storm event. Lauren, would you mind telling us a little bit more about the planting plan and anything else you want to add to the design?
Certainly. Thank you, Erica. So my profession is as a landscape designer, landscape contractor. And what we've done with this planting design is we've used native plants that are really attractive and also provide a lot of ecological function. And the way we've planted this out is that so it will be lower maintenance, meaning that we plant very thickly, very tight, in order for our areas that we plant to not need the same amount of maintenance, because the plants grow in very thick and then weeds don't really come in. So some of the plant materials that we've used here are plant materials that you would find naturally in this area prior to, our disturbance of the area. So some of them are like the red berries are the winterberry hollies. We use native grasses like the panicum there, which is to the right, lower right-hand corner. And we also use a plethora of different kinds of perennials that have a lot of wildlife and pollinator value. So like black-eyed Susans, black-eyed Susans, some swamp milkweed, plants that do well in these sorts of gardens and these type of settings. The important thing to remember too is that we have in here 2 river birches, and we also are using some shrubs like button bush and Itea, and some viburnums, which are called winter trip viburnums, that have really great fall color, pretty flowers, and are very, very durable. So unless anybody else has any additional questions, that's kind of an overview of the plantings that we have there. So right now, that area is overgrown and not really been taken care of. This is a much more attractive response that will need less maintenance in the long run.
Thank you so much. And thank you for sharing all of those beautiful plants that we're going to have there. Just to move forward, we are really close to starting construction. When you see the signs go up at the site, that means our construction is going to begin. But we want to go through a few of the details for you so that you know what to expect. So first of all, construction access. Even though the site is on one side of the recreation center, the road to get there, and all the construction is going to be on the other side. So as you can see, there's going to be a construction access zone. We're going to be covering up that ground with wood chips to keep the turf safe for the baseball field, the baseball diamond, and then that construction site will be happening over there behind the basketball courts. There'll be no public access when we're doing construction, so we're going to do our best to make sure if you use that hiking path or that jogging path, that we'll just divert it so you can go around the baseball diamond for now. General information. All work occurs on weekdays, Monday through Friday. Work hours are 8 to 5 p.m. Construction vehicles you'll see on site is one skid steer loader, one track excavator, a stake body truck, and a crew pickup truck. The DOEE community point of contact is Cecilia Lane and myself. I'm going to add to you all my contact information so that you all can email me or Cecilia if you have any questions. So site access and parking restrictions. There's no public parking restrictions. Workers will be parking on site. As you know, there's really no parking in that area except for the small parking lot by the pool, which is generally for employees. So really nothing should change there. The work area will be fenced off for security, so no pedestrians will be able to walk through that during construction. Our project timeline, as you can see in yellow, we are in the construction kickoff meeting. So we've already gone through 3 public meetings, the concept design, the semi-final design, and we are ready to start construction. This started in May 2019. So we've done all of the surveys, we've done all of the design, and NRS is really excited to get started. It'll take approximately 6 weeks for construction. And just so you know, there's 1 year of post-construction maintenance included in this contract to make sure that the bioretention and the practice is working up to the level that it needs to be to capture that water and infiltrate it. So now we just have a page about facts. How do we find our project sites? There's a whole bunch of different project sites that DOEE does. Some of them are on our partners' land, like Peter with Department of Parks and Recreation. DOE itself only has one piece of land in their inventory, and that's Kingman and Heritage Islands. Otherwise, everything else are other landowners within the DC family. Our funding sources are varied between federal funds, local funds. This one specifically, the funding can only be sent in the District of Columbia. How do we choose these projects? Well, we want to make sure that they're large areas of untreated impervious cover, like this image here on the right, this really, really large parking lot. And preferably, it's an area that, didn't have the specifications. So that was done a long time ago. And so we're trying to retrofit or change it up to the current specifications and then some, so that we can help to clean the water. And we also choose more impactful locations. What can you do? Okay, there is something you can do. We have this awesome program called RiverSmart. You can check us out, riversmarthomes.org, where you can get a bunch of different things installed in your own property. If you're a homeowner, or you can work with potentially, the homeowner of your apartment to install rain gardens, permeable pavers, rain barrels, tree planting, and basecaping. Basecaping is really cool because you get to choose a whole bunch of different plants that can go in your yard, and it makes it look really beautiful, and you can get some pollinators to come. Tree planting, who doesn't like a beautiful tree in the fall or the spring blooming and its leaves changing? Rain barrels are really awesome because they can capture a lot of rain coming from your rooftop, and then what you can do is you can actually use them to water your garden. So really great thing to pursue. Permeable pavers, a little bit more expensive, but they're really going to capture and absorb that water, and that will replace like concrete in your driveway with these pavers that are permeable instead of impervious. And rain gardens. So before I go on to the questions, I just wanted to reach out to all of my colleagues and see if they had anything else to add. Peter, Cecilia, or Lauren, before we go to questions.
Thanks, Erica. You did a great job going over the presentation. And just a reminder to anyone who is listening on the line, if you have questions or comments, please put them in the chat box. We can respond to them. The construction timeline, sorry, go right ahead.
Oh, no, thank you for the presentation. I thought it was really thorough and informative, and I'm here as well if people have questions for DC Parks and Recreation. Thank you.
Peter.
So, interesting. Yeah, so I should have reminded everyone that, well, we do have the Q&A, so I almost missed it. And the question is, I am an NIGCP, or I guess it's NGICP graduate, and I have a small business installing rain barrels, working on getting into rain gardens and basecapes as well. I'm interested in working on this project, if even as an intern. How do I go about that if possible? Lauren, did you want to speak to that? I know we've had some
I'm happy to
in the
speak to that.
past. Go right ahead.
What I'd like to invite you to do is to email me directly, because we are the contractors on the site. This project is going to move very fast, is our anticipation, and I would hope that we would be able to get started on this project in the next couple days. So one of the things that I wanted to say, so my email address is lauren@naturalresourcesdesign.com. And you are welcome to email me and send me your phone number, and I can give you a call and we can have a conversation. So in ways in which you might be able to be helpful. We're not using any rain barrels for this particular project because they are renovating the building, is my understanding, in the future. So we're just limiting the bioretention cell, the work to the bioretention cell next to the basketball court. So I'm happy to speak with you, meet with you, and discuss how you might be able to be involved in this and perhaps other projects.
Thanks, Lauren. I put Lauren's contact information in the chat box. For whatever reason, the Q&A is not as functional for us, so I can't add it there. So you should be able to access that in the chat. Yeah, I just wanted to touch base on the timeline for this project. We are mobilizing starting tomorrow. While we estimate 6 weeks for construction, as Lauren noted, they're moving very quickly at these projects, so it would probably be significantly less. However, obviously we can't work when it's raining, we can't work on holidays, we don't work on weekends, so that does have an impact to our timeline. But starting tomorrow, you'll start to see trucks and fencing and things out at the site. Okay, I'm gonna look, it looks like, okay, the person inquiring about the intern or experience, Lauren, says thank you. Okay, any other questions for us on this project or the site? Okay, here we go. Ooh. Just a second, we got one coming in here. Okay. My name is Kathy Poole. I'm a construction manager with RK&K. We are an engineering and construction management firm with extensive experience in stormwater management and green infrastructure design and construction management. We are providing construction management for the DC Clean Rivers GI program and also have a role on the Northeast Boundary Tunnel project. We would like to get plugged into DOE's stormwater management efforts. How do we do that? Thanks, Kathy, for the question. You can give me send me an email directly, and I'll put my email information in the chat box and request to be added to our vendor list. I'm going to turn around and send you a form that you fill out that helps us understand your firm's expertise. I actually believe we have RK&K on that list, but we have an old contact, Meredith Upchurch, who has since moved on from RK&K and now works with DOEE. So I'd be happy to send you a form so you can update RK&K's contact information for new RFP opportunities. So I'm gonna put my contact information in the chat box right now. Fabulous. Any other questions on this project or the site? Lauren and Chris, please note that Peter did ask that we keep our access road, our stabilized construction entrance as far from off the field as possible in consideration of spring baseball, since it's the grass is going to need to take root before it can be played on. We are running, kind of walking that thin line between staying off the field and then staying off of the existing infrastructure. There's a number of yard inlets on the site that we're trying to avoid. Okay. All right. Well, it looks like we don't have any more questions coming in, although I suppose I can try to unmute everyone and see if I'm going to unmute our 3 participants and see if they have any additional questions for us. All right, you guys are all live. Do you have anything you'd like to ask regarding the project? Hearing none, I'm going to assume that we did a thorough job explaining everything.
Yeah, absolutely. There's no questions on this side. This is 7. And again, thank you guys for this opportunity. I really do appreciate
sure. Thanks, 7, for
hear about the project and see all of the detail. It's awesome. Thank you guys.
Thank you for participating. No, okay, hearing none, I'm going to say that that's probably everything for this evening, Erica. So if you want to wrap up. Just as a reminder, we did record this meeting. We'll put the slides and the recorded version on the project website. It does take a few days to process that, but it should be up there within a week's time. Thank you so much for the meeting.
I just want to say thank you so much, everybody. I look forward to this project getting started, and I hope you all have a really good and safe evening.
Okay, same to you guys. Thank you, guys.
Thank you so much. Thank you. Bye-bye.
Bye-bye.